This is a meeting of the Ojai Basin Groundwater Management Agency on June 24th? 5th, June 25th at 3 o'clock. Call to order. If you call the roll.
Director Daddy? Here. Director Weaver?
Here.
Chair Hages?
Here. Stand for the Pledge of Allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, next item here. Director comments. Mike.
Yes, nothing from the mutuals.
Bob.
Nothing from the district.
I don't have anything from Casitas. General Manager comments.
Good afternoon. I do want to mention that we've been chipping away at well owners who are delinquent on submitting their extraction statements and going through some of the more egregious ones, and probably over the next few months sending out a lot of notices to bring them before the board to potentially impose fines and penalties. Notices went out yesterday to 3 well owners for potentially having a hearing at the July meeting. So if we don't get those resolved with those well owners, you'll see them on the next agenda. And then you probably saw my email that the city of Ojai is going to be bringing in action to suspend their well ordinance. So once they take that action, we'll move forward with our monitoring wells and get those installed. And that's all I have to report.
Okay, Basin status report. Jordan?
Indeed. Let me share the screen. Start a slideshow. Given that we were absent last month, we decided to talk about the baseball style this time of year. Let's play 2. So we'll talk about May and June conditions here in Ojai for today's meeting. A little bit more precipitation fell up top on Nordhoff Ridge, so 53.11 inches year to date for the water year up top in the recharge areas, and 27.89 on the valley floor. No precipitation on the valley floor in the past month, but a little bit up top. What that has done to the groundwater levels, we're still very high with respect to our longer term averages and, more importantly, drought conditions or even summer conditions most of the time. Last month, the depth to water was 68.40 feet in the Key Well, or about 92% of capacity at 73,600 acre feet. And then this month, it went down a little bit more. We're still only 30 feet deeper at the Elrod well than we were at our peak back in March. 78.46 as of yesterday, 90% capacity, or 72,000 acre feet. Surface water budget last month, 27 May. A little bit of flow still coming in at Gridley and Reeves. Outflow at Montgomery or Fox, 0.37 CFS. Surface flow out, 10.76 CFS, the main portion of San Antonio Creek. At Ladera Bridge, 1.58 CFS coming down Senior Canyon. The total inflow was 2.05 CFS, effectively all of that going into the production aquifers. And the outflow was 11.13 CFS, effectively all of that coming from the uppermost saturated zone. The surface water budget yesterday, and these are just snapshots taken when we can. Gridley was down to 0.05 CFS, Thatcher was dry, Reeves is now dry. Almost 0.2 of a CFS out from the western side, and 8.49 CFS out via San Antonio Creek proper. Ladera Bridge was about half the flow that it was the month before, 0.78 CFS, for a total inflow of 0.83, again, all going to the production system, and the outflow of 8.68, effectively all coming from the perch system. All right, well, we talk a lot about this perch system, and every month I try to bring some new insight about it, because we're always studying this, we're always learning this, and part of the scientific method is even if you're right about something, you want to test that theory with every possible angle that you can. It outlined in the purple here is the current understanding of the southwest uppermost saturated zone of the basin, and the so-called, formerly known as the perch system, but the SWUZI was a pretty good acronym to come up with. Now that aerial extent is about 2,735 acres, but importantly the drainage area is all of Stewart Canyon, all of the Fox Barranca, all of the East Ojai Drain exclusively feed that system, as well as some of the north side of Black Mountain to the south. And assuming that 2,735 acres has about 10 feet of saturated thickness, the volume of the aquifer is 27,350 acre feet. That's the rock and the water. 30% of that is space in which water can be between grains of sand and gravel, which means the volume of water within the perch system is over 8,200 acre feet. That's about 10% of the basin capacity. The drainage area looks something like this. Outlined in this light blue is that almost looks like an island in profile, but it's that entire western side of the basin drains exclusively to the perch system. Doesn't go anywhere else. It goes either out San Antonio Creek and Fox Barranca as surface flow or finds its way into the uppermost saturated zone, including septic and irrigation return flow in that area. Now, in sketching this out, the tributary area is about double the alluvial area. So it's a 2-to-1 ratio. What rain falls is twice as much as what happens in the aerial extent. But if we assume 30 inches of average rainfall, like this year, 2025-26, we had about 12,870 acre feet of input. And again, that's about 10% of the entire basin capacity. So more was coming into this system than the roughly estimated amount of water in storage within that area. And of course, we have a couple wells that have been drilled, right, in this one recently in May, up Mercer, for the Norris and Vanderfins. We got a good amount of data from that particular well shown there in yellow. In fact, if we take a look at some of the cuttings, you can see exactly what the perched aquifer looks like in that area. Each of these boxes in this chip tray is about a 5-foot representative thickness of the aquifer. So 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25, 30, there at the top upper right. And if we look at that from a standpoint of that is what the perch system looks like. It's that 10-foot thick zone that we collected samples to make sure that the seal in this particular well went all the way through that in compliance with OBGMA ordinance number 12, all the way down to 50 feet would be adequate. And most of the wells in that area comply with that by nature of complying with state and county standards, but more importantly, the OBGMA has enacted ordinance 12, making sure that none of that water that goes into that perch system is extracted by wells. So the SWUZI water levels that we monitor in both the Ojai Valley Sanitary District monitoring wells and in the South Fulton Street depth discrete monitoring well is a great, the water levels are a great proxy for a number of things. One is the saturated thickness of the aquifer. If it were dry, it'd be 0. This is on the left here, that light green material, light green color numbers, 0 to 26 feet, based on logger data that we collect at very high intervals throughout the basin. But here, it's that saturated thickness is represented by the water levels in those wells. Now, the perched aquifer storage is also a factor is also a result of the factor of the thickness of storage. When it's full, you get upwards of that 10,000 acre feet amount of storage. If it were dry, which in the past few years it hasn't been, it would be 0. But we get probably around 4,000 acre feet at the minimum way back in 2022, before the 2023-24 rains. It's also a proxy for San Antonio Creek flow. Roughly, just based on correlations of measurements we've collected and correlating that to water levels in these wells, San Antonio Creek flow, the CFS therein, would be about 0. This is on a logarithmic scale, as is typical for surface flow hydrography. 0 at the bottom and about 1,000 CFS at the top of this graph. So when we're measuring today about 10 CFS on the far right side of the graph, that's about where the water levels are in the Swazi wells. Make sense? It's a beautiful thing, I think. But what does it look like in real life? So over the past couple months, last month we had a little bit of algae-ridden inflow at Reeves Creek. Yesterday, it's all dry. The algae remain, but it's the algal mat of desiccated algae. Stewart Canyon was dry last month, actually since April. Thatcher Creek's been dry for a while. A couple different angles of what that looks like over the past few days. Still have flow in Senior Canyon under Ladera Road Bridge. 1.58 CFS looks about like that in May, and 0.78 from downstream, looking up, under Ladera Road Bridge, about half of that yesterday. Over at Gridley Creek, we had 0.3 CFS last month, and this month it's a lot drier, and you see it's almost like a puddle where you have that 0.05 CFS flowing. At the confluence of Gridley and Senior Canyon, where San Antonio Creek has its nascent confluence at the dry road crossing, you can see last month still relative clarity of water just past the road crossing, a lot less yesterday, and starting to see more algae there, but not a tremendous amount of algae by comparison to further downstream. Boardman Road, the Hartman well, was flowing artesian through April, and by May it was dry, by the end of May at least. And when I say dry, it was not flowing artesian. The well's not dry, far from it. As of last month, we still did, though, have flowing artesian conditions, however slight, in the depth discrete monitoring well and the correlative aquifer therein that correlates to the Hartman well. Of course, by the end of April, the surface flow was discontinuous, looking up and down from some of the bridges across San Antonio Creek. And then on the discharge side, Fox Creek underneath Creek Road, 0.37 CFS looked about like this last month, and 0.19 CFS, about half that, outflow as of yesterday. At San Antonio Creek proper, on the exit point at the basin, last month we had 10.76 CFS outflow on San Antonio Creek. Of course, the county gauge at Camp Comfort was reading 211 CFS, and so we're just continuing to make a note of that order of magnitude plus discrepancy. And then yesterday, 8.49 CFS outflow at San Antonio Creek and 196 CFS at the county gauge at Camp Comfort. So owing to changes in elevation, a bit more sediment, and yet to be made corrections, we see that significant discrepancy. On the discharge side of San Antonio Creek, near the confluence with the Ventura River, looks like there's a lot more flow there. It's really just shallower, and there's quite a bit of algae flowing. As of yesterday, we measured just over 10 CFS. It was about 35 CFS per the county website. So, yeah, roughly the same order of magnitude, but still off by a factor of 3, which is closer. I guess pretty good if you're off, if you're hitting 300 in baseball, but you know, let's play 2. As a month ago, it was 53 CFS on the county website, and the measured flow was 11 CFS. We do have the El Nino Southern Oscillation, ENSO outlook, predicting El Nino conditions that you may have heard. Super El Nino, you may have heard. All sorts of different predictions coming from different sources. NOAA officially, as of this past month, predicted El Nino conditions likely for May, June, July, with a probability of slightly greater than 70%, strengthening in the summer and the autumn seasons. That means for us, really, this summer it's probably warm, maybe humid, maybe some chubascos coming up from the south, hurricane arms, and we'll see what that brings us. But the longer-term prediction really just says normal for winter, which around here, if we get 21 inches of rain, that's normal on the valley floor. Does it take a super El Nino to do that? Obviously not. We'll take what we can get, and hopefully it's not too damaging.
Not all at once.
Not all at once. Any other questions?
Any questions? You know the difference between the bottom elevation of the Swazi and the outlet to San Antonio Creek?
Off the top of my head, I don't, but the outlet is certainly the lowest of those points.
Yeah.
And the gradient is very similar to topography. We're only looking at, the Swazi has a very large area, obviously 2,700 acres. There are places where it's 1,000 feet above sea level. And the elevation at the basin outflow, I think, is around 640. So it's a pretty good gradient.
Yeah.
Can keep those flows coming.
Any other questions? Thanks, Jordan.
Thank you.
Okay. Next item is public comments on items not on the agenda. Bill Wyrick.
Always learn something here, Jordan.
Me too.
I do appreciate the county's dedication to accurate measurements and their pursuit of the scientific method that depends on it. Anyway, today I wanted to make a comment that I sent a copy to Richard that I would, the county civil grand jury released today. Giant Reed, Giant Problem, Arundel and Ventura County. And I noticed that you were not on the distribution list for comment, or was CMWD. And I would just ask that you consider, given this action at the grand jury level, talking about the importance of coordinated and collaborated Arundel eradication for both fire risk reasons and watershed health reasons, that you consider some sort of positive communication to the grand jury, thanking them for this, and possibly the other agencies involved in terms of upping the game, so to speak, which is basically what the grand jury is asking for. It said that we have a problem with the lack of coordination and collaboration at the county level, and that they have a series of findings asking that this occur, and the importance of it occurring. And I would think, especially in light of the attention on fire risk, and I would hope that this kind of thing might be able to help with inclusive language in the adjudication settlement, of which I know nothing about, of course. But I'm just here to request that you consider putting on the agenda some sort of support or review for this effort by the county. The county grand jury. There was one commendation. The commendation was the Ojai Valley Land Conservancy, highlighted for their work, and I think it would show that they need additional support. And I believe the author was our very own Chelsea Satula, by the way. So anyway, that's what I'm here for, to ask that the water agencies in the Ojai Valley consider finding a way to leverage this report that was released today in terms of upping the effective game in the Ojai Valley for Arundel eradication. Thank you.
Thanks, Bill. Any other public comments? Okay, the consent agenda is next. We've got the financial report for April and May, and the minutes of the April 30th meeting. Any questions or comments?
I make a motion. I make a motion that we accept the report.
Second.
Call the roll?
Director Daddy?
Yes.
Director Weaver?
Yes.
Chair Hages?
Yes. Okay, discussion items. Groundwater Sustainability Plan, 5-year periodic evaluation of water quality analysis.
So Dudek has been working on the 5-year periodic evaluation for us, and one of the tasks is to do an evaluation or analysis of the water quality in the basin and how it's changed over the last 5 years. And so Devin from Dudek is here, and he's going to do a 10 to 15-minute presentation on their findings.
Thank you, Julia. I've shared my screen. Can you see the slides?
Not yet.
Okay.
There it is.
Okay, we may have a delay today, but we'll see how it goes. Okay, well, thank you. As Julia said, I'll be giving a groundwater quality update. So jumping in. Groundwater quality in the basin is monitored on a regular basis by 3 primary entities, including Ojai Basin Groundwater Management Agency, Ventura County Watershed Protection District, and operators of drinking water wells who report data to the State Water Resources Control Board Division of Drinking Water. The monitoring includes collection of a wide array of minerals, metals, and organic and inorganic chemicals, of which there are 7 constituents of potential concern in the basin, including total dissolved solids, or TDS, sulfate, chloride, boron, nitrate, iron, and manganese. The groundwater sustainability plan included water quality data for the period from 2010 to 2020. So today we will review the recent water quality data collected over the last 5 years between 2021 and 2025 and make comparison to what was included in the GSP, or Groundwater Sustainability Plan. And we will also review trends in water quality at individual wells. So starting with total dissolved solids, TDS, the maximum concentration of TDS measured over the last 5 years between 21 and 2025, the majority of wells have a TDS concentration of between 600 and 1,000 milligrams per liter, as shown by the green and yellow circles. Of the 23 wells sampled, 3 wells have concentrations above the secondary maximum contaminant level, or MCL, of 1,000 milligrams per liter. And those are denoted by the red circles. Now, when comparing the maximum concentrations measured between 2010 and 2020 to the max concentration measured between 2021 and 2025, TDS concentrations increased in 5 wells and decreased in 16 wells. Of the 5 wells that showed an increase, just 1 well showed a significant increase of 440 milligrams per liter. And that well is shown in symbolized by the yellow circle. Moving on to sulfate. The majority of wells have a sulfate concentration of between 0 and 250 milligrams per liter. None of the wells sampled have a concentration above the secondary maximum contaminant level of 500 milligrams per liter. Looking at the change in max sulfate, concentrations increased in 13 wells and decreased in 8 wells. However, of those 13 wells that showed an increase, just 1 well showed a significant increase of 157 milligrams per liter. The same well that showed the significant increase in TDS. Moving on to chloride. The majority of wells have a chloride concentration of between 0 and 125 milligrams per liter. None of the wells sampled have a concentration above the secondary MCL of 500 milligrams per liter. And now comparing the change in max chloride concentration, concentrations increased in 9 wells and decreased in 12 wells. Of the 9 wells that showed an increase, again, just one well showed a significant increase of 135 milligrams per liter. The same well that showed the increase in TDS and also sulfate. Now boron. The majority of wells have a boron concentration of between 0 and 0.1 milligrams per liter. None of the wells sampled have a concentration above the notification level of 1 milligram per liter. Now looking at change in boron, the change in max boron, boron concentrations increased in 1 well and decreased in 21 wells. The concentration in the 1 well that showed an increase was not significant. It was only 0.1 milligrams per liter, with the notification level for boron being 1 milligram per liter. Nitrate, so this is nitrate as nitrogen. About half the wells have a nitrate as nitrogen concentration of between 0 and 5 milligrams per liter, and the other half have a concentration of between 5 and 10 milligrams per liter, with one well having a concentration above the MCL of 10 milligrams per liter in the eastern portion of the basin, as denoted by that red circle. The change in nitrate, nitrate concentrations increased in 10 wells and decreased in 11 wells. Of the 10 wells that showed an increase, the maximum increase was approximately 1.5 milligrams per liter, so relatively small. Iron, the majority of wells have a max iron concentration of between 0 and 0.15 milligrams per liter. One well has a concentration above the secondary MCL of 0.3 milligrams per liter, but overall iron concentrations are low. Looking at the change in max iron, concentrations increased in 1 well and decreased in 20 wells. The concentration in the 1 well that showed an increase was not a significant increase, only 0.05 milligrams per liter. And lastly, manganese. So 2/3 of the wells have a manganese concentration of less than 0.01 milligrams per liter, and 1/3, or 8 wells, have a concentration above the secondary MCL of 0.05 milligrams per liter. So elevated manganese is relatively widespread or common in wells across the basin. And looking at the change in manganese, manganese concentrations increased in 3 wells and decreased in 17 wells. Of those 3 wells that showed an increase, just 1 well showed a significant increase of 0.25 milligrams per liter. In addition to looking at the max concentrations and the change in maximum concentrations, a trend analysis of water quality data was also performed using the Mann-Kendall test, which is a statistical test used to identify monotonic trends in time series data. Wells with greater than 4 data points were analyzed using a significance level of 0.05 or 95% confidence level. Data from 21 wells was used in the analysis, of which 5 wells showed an increasing trend, and the remaining wells either having a stable or decreasing trend. And so of those 5 wells that showed an increasing trend, 2 wells had an increasing trend in chloride, 2 had an increasing trend in nitrate as nitrogen, and 1 well showed an increasing trend in sulfate. So looking at the 2 wells with an increasing trend in chloride and 1 well with an increasing trend in sulfate, these graphs are fairly small, but on the y-axis there, you can see the concentrations. And as you can see, the increases in concentrations are relatively small, and measured concentrations themselves are less than half the MCL or lower. So although concentrations are increasing at these 3 wells, the increases are not a concern at this time. Looking at the 2 wells with an increasing trend in nitrate as nitrogen, concentrations have increased by approximately 1 to 2 milligrams per liter over the last 20 to 30 years, based on that data record there, and are currently concentrations are approximately 1/2 the MCL or slightly higher. So between the 5.5 to 6.5 milligrams per liter. Trends at these 2 wells will continue to be monitored to see if these concentrations continue to increase or stabilize over time. It is important to note that these concentrations are for raw, untreated groundwater and not the treated water served to customers in the basin, as these are both municipal supply wells. So, in summary, concentrations of the 7 constituents of potential concern are generally stable. TDS, nitrate, and manganese were detected at elevated concentrations in a few wells, while sulfate, chloride, boron, and iron are all below drinking water limits. There are a few wells that show increases in max concentrations, but concentrations in the majority of wells have remained the same or decreased in recent years. The increases observed at the few wells appear to be isolated to individual wells and a result of either local well conditions or natural variability in water quality. But that said, some additional analysis is being performed currently to evaluate correlation between water quality and other variables such as precipitation, groundwater levels, groundwater extraction, and well depth to see if water quality is correlated, and those results will be included in the 5-year periodic evaluation. And with that, available for questions.
Any questions? Do we take any water quality samples in the PERT zone, whatever we do?
Yes, the South Central Depth Discrete well was recently sampled, and sampled also following the installation, and then Jordan can speak to some of the others.
Short answer is yes, we do indeed collect samples from those, and they've been relatively stable over time. I think there's 2 data sets that are included in the analysis Devin went through for the South Fulton Street Depth Discrete Monitoring well. There are also quite a bit of water quality data available from the environmental monitoring wells that have been scattered throughout the area and the city over the years, but most of those tend to be contaminants of concern, like gasoline-related compounds and solvents. But again, short answer is yes, we do collect some samples.
Okay, thank you. Any other questions? Well, thank you very much. That was very informative.
You're welcome.
Okay, next item is a status report on the watershed adjudication. Unless somebody else has any information, I don't have a lot. The hearing for scheduled on Friday's been canceled and rescheduled for July 1st. So in general, we're still negotiating. I think the local parties in the city of Ventura and Casitas and Ojai are very close, but there's still some significant issues between us and the state. So that's pretty much where we're at right now. Okay, do we have anything on the legislative ad hoc committee? Okay, meter compliance. Good. Okay, if there's no other business, we are adjourned at 3:34. Well, it's good to know the water quality's doing well. Got flushed out really well in the last few years. I'm sure it wasn't as good